Let's look at exercise 21 from section 8.3. The carry-it-all minivan, a popular vehicle among soccer moms, obeys the demand equation P for price equals negative 150x plus 8,000. The cost of producing X vans is given by the function C of X equal 4,960x plus 30,000. We want to express the revenue as a function of X. Revenue is the cost per unit for whatever the company is making times the price for each unit. So in our case, that would be X, the number of vans produced and sold, times P, the price of those vans. P is negative 150x plus 8,000. When I multiply that by X, I get negative 1 over 50 x squared plus 8,000x. So that's my revenue function. P of X, capital P of X, is the profit function. And that's always the revenue, the money coming into the company, minus the cost function, the money going out of the company. So that's minus 150x squared plus 8,000x minus 4,960x plus 30,000. Most students would stop here, leave this as the cost function, combine the like terms, and this would be incorrect. Because when you subtract the cost function, you have to subtract not just the 4,960x, but also the 30,000. So you need to be thinking of that in this way, where those two are grouped together. The two terms of the cost function are grouped with a grouping. Even if you don't write that step, you have to think it. So the profit is negative 1 over 50x squared plus 8,000x minus 4,960x, which is 3,040x minus 30,000. So this is my profit function. We're asked to find the value of X that maximizes profit. So that essentially means, since this is a quadratic function, I'm trying to find the X that equals minus B over 2A, where B is the coefficient of X, 3,040. A is the coefficient of X squared, which is negative 1 over 50, which as a decimal is negative 0.02. So this is negative 3,040 divided by negative 0.04. And when I carry out the division, I get 76,000. So the quantity of vans that maximize profit is 76,000 vans. Now we want to know what is the max profit. Well, that's the profit function, capital P, evaluated at 76,000. Minus 1 over 50 times the square of 76,000 plus 3,040 times 76,000 minus 30,000. And so I let the calculator do the calculating, and I get that the profit function when 76,000 vans are sold is 115,490,000. So that's actually my max profit, 115,490,000. And then I'm asked to find what price should be charged to maximize profit. And of course, I simply need to use the price function, lowercase p, equals minus 1 over 50x plus 8,000. And I replace X with 76,000. And I let the calculator do the calculating, and I get 6,480. So if the price of each van is $6,480, the profit is maximized.